Hello and welcome to lesson 3.2, Solving Systems of Equations Algebraically. So today we're going to learn how to solve a system of equations by substitution and by elimination. For the substitution method, we're going to get one variable alone, then we're going to substitute the expression that the variable is equal to into the other equation. So we're going to start by trying to get one of the variables alone. Realize that you have four variables, x, y, x, y. Of those four variables, do a little competition first. See which variable already is most alone. Is this x alone, or this y, or this x, or this y? I think this one is already most alone. Okay, so it wins the competition. It doesn't have any coefficient on it. So it's going to be the easiest to get alone. Always look for the variable that doesn't have a coefficient and that has a coefficient of 1 and get that one alone. So I also sometimes like to call this my A equation, my B equation, just so that I can talk about them a little bit more specifically. So I'm going to start with my B equation and get x alone. That means get rid of this neighbor. Solve for x. X equals negative 2y plus 2. You say that's not very exciting. True. But it is still something. We know what x is equal to, negative 2y plus 2. If that's what x is equal to, well, here is another x. So let's work with plugging everything that x is equal to into that x. So I'm going to go to the A equation now. 3, everything that x is equal to, negative 2y plus 2, close it up, continue writing that A equation, plus 4y equals negative 4. Okay, now go back to algebra land and just distribute and combine like terms and try to get your y alone. The cool part about this is now we only have y's left. Okay, negative 6y plus 4y is negative 2y. Okay, move your 6 over. Negative 2y equals negative 10. Divide by negative 2. Y equals 5. Okay, here's your x expression. So x is equal to negative 2 times 5 plus 2. And so, sorry, I went through that kind of quick there. Now what we're going to do is we're going to go back to that bracketed equation right there and solve for x. So x equals negative 2 times y plus 2. And that's x equals negative 10 plus 2, so x equals negative 8. And the last step is to write them as an ordered pair. So x comma y is equal to negative 8 comma 5. All right, let's go through that process again. Number 2, solve the linear system using the substitution method. We should therefore only use the substitution method when we have a variable with a coefficient of 1. So look for that variable with a coefficient of 1. If you had many variables with a coefficient of 1, then you can solve for any of them to start. I'm going to solve for this y. Okay, I'm actually going to add it to the other side just so that it's positive and subtract my 13 over. So here is my new A equation. Y equals 3x minus 13. Okay, put a little bracket around it. Step 2, substitute that into your opposite equation. If that's your A equation, go to your B equation, and if you know what y is equal to, then plug it in for y. Okay, distribute your 2. 2x and 6x is 8x. Add your 26 over, equals 16. Divide by 8. x equals 2. Okay. Then take your x equals 2 and put it into your previous bracketed equation. Y equals 3 times 2 minus 13. 3 times 2 is 6. Y equals 6 minus 13. I know that is 7. Okay. Now, last step, write it as an ordered pair, x comma y. That is 2 comma 7. And that's how substitution works. Can you do the next one all on your own? Ready, go. Okay, let's see how you did. First thing, we should have done a little competition and seen which variable has a coefficient of 1. It's this x here, so we should get that x alone in the b equation. Next, go to the opposite equation, the a equation, and plug that in. If this is what x is equal to, then let's plug it in for x. Two times 5 is 10y, plus 18 plus 3y equals 5. Okay, and then I'm going to combine my y's and get 13y. I'm going to take away this 18 and get negative 13, and y equals negative 1. Plug that into the previous bracketed equation. Negative 1 goes in for y. Okay, and then that's negative 5 plus 9, x equals 4, and put it as an ordered pair, 4 comma negative 1, in the order x, y. Okay, let me show you the elimination method. Okay, first we're going to multiply one or both equations by a constant to obtain coefficients that differ only in sign for one of the variables. Add the revised equations and combine like terms and eliminate one of the variables and substitute the original from step 2 into one of the equations. Okay, so substitute the value obtained from step 2 into one of the other equations. Okay, solve the system by the elimination method. What I'm going to do is do a little competition here that's a little different from my previous competition. I'm going to look to get two of these to be the same value but opposite signs, and I try to multiply as little as possible. I could get these two to both be 4s if I multiply the top equation by 2. So that requires me only multiplying the a equation. I could get these two to both be 20 if I multiplied the top equation and the bottom equation by 5 and by 4. Well, I'd prefer to do the less work route, so I'd prefer to just multiply one of the equations. So I'm actually going to try to match up these x's by multiplying everything by negative 2 though, because I really want them to be opposite signs. Negative 4x plus 8y equals negative 26, and 4x minus 5y equals 8 is the traditional, the original b equation. Okay, double check your work. This became a negative, this became a positive, that became a negative. Everything looks good to me. 2 became a 4, 4 became an 8, 13 became a 26. Okay, and then these copied down perfect without any sign errors. I think we look good. All right. Now, let's add them up. So I'm going to do a linear combination and add these equations. I get 3y equals negative 18. I know 6 goes into 18 3 times. Okay, so that's all my first column of work. It's pretty quick to go ahead and get your first variable. Your second variable takes just a little bit of wrestling, because I don't have an equation that already has the first variable solved for, but that's okay. So I'm just going to choose either equation. Let's say I like the b equation. 4x minus 5y, which is negative 6, equals 8. So 4x plus 30 equals 8. Take away 30. 4x equals negative 22. divide by 4. It doesn't go in perfectly evenly, but that's okay. Negative 5.5. Now I just need to do my ordered pair, x, y. Many students like elimination more. They think it's faster. I think when I really compare step by step, it's very close. Okay, it just has an earlier win because you get that first variable so much easier. All right, so let's try the next one. Notice the title. We will have to multiply both equations this time. We can't get around it. A 7 and a 5, one can't become the other by multiplication. They both would need to be multiplied in order to get 35. 12 and 8, they would both need to be multiplied to get 24. Okay. I kind of like the 24 route myself, so I'm going to go that route. 12 times 2 gets me 24. 8 times 3 gets me 24. So that's 14x minus 24y equals negative 44, and negative 15x plus 24y equals 42. Okay, then let's go ahead and add up and cancel. And what do we get? We get negative x, and negative 44 plus 42 gives you negative 2, and negative 2 divided by negative 1 is positive 2. So when you substitute that, positive 2, I'll substitute it into the second equation. Negative 5 times 2 plus 8y equals 14. Negative 5 times 2 is negative 10 plus 8y equals 14. Add 10 to the other side. 8y equals 24. Y equals 3. Then take the combination of 2 and 3, and there you have it. Okay, now try a linear system with no solution. Let's try the elimination way again. So I'm going to multiply to cancel x's. I'm going to multiply by negative 2, because then it will give me x's with the same value but opposite signs. So my A equation is now negative 2x plus 4y equals negative 6. My B equation is 2x minus 4y equals 7. What do you notice? We know that with elimination, we're going to add vertically. My x's are going to cancel, my y's are going to cancel, and I'm going to have nothing on the left. Negative 6 and 7 is 1 on the right. This is false. So therefore, there is no solution. Make sure that you actually do cancel them out and get it to be a 0, because if the right-hand side canceled as well and became a 0, 0 equals 0 is true, and we would have infinitely many solutions. So here we are with that scenario. 6 and 15 and 10 and 25. 6 and 15 can be the same value when they're 30. So I'm going to times everything by 5. And 15 needs to be multiplied by 2 to be a 30. 6 times 5 is 30x minus 50y equals 60. And down here, negative 30x plus 50y equals negative 60. So what do you see now? We see that these will cancel, and these will cancel. So you technically have 0 equals 0, which is true, which means infinitely many solutions. Okay. All right. Turn this over. So say that you get to choose the method, and that you'll have one of these on your quiz. Choose a method. Do you want to do elimination or substitution? Normally, you'd probably go substitution, especially when you have a variable on its own. In this case, though, you'd never go substitution, because you don't have any variables with coefficients of 1. Okay? So always go elimination. All right, so choose the method. Which method would you choose? This looks like a traditional elimination problem because first off, 5 and 5, those are all set to be canceled, except you just need to multiply one of them by -1. So it's screaming elimination! But also, don't ever do substitution to something that doesn't have a coefficient of 1, because to divide off the 3 or the 5 or the 5 or the 7, to make it so that you have a coefficient of 1 on the front, will make everything have fractions, and it will be trouble city. Okay, so let's multiply it by -1. I get 5x minus 7y equals -11, and -5x plus 3y equals 19. Add it up. So 7 and 3 gets me -4y. 19 minus 11 is 8. -4y equals 8. Divide by -4. Y equals -2. All right. Next, go ahead and plug in to the other or to either equation. I'm going to use the top one. -5x plus 7 times -2 equals 11. -5x minus 14 equals 11. -5x equals 25. X equals -5. So we get -5, -2. Okay, and I'm going to stop there. Thank you for joining me.